Building technical skills for employability in Industry 4.0. Every enterprise requires resources, which are called as 4Ms: man, machine, material, and methods. In Industry 4.0, the machine is going to change. The machine is going to be controlled by internet. So internet will control the total machine, it will guide the flow of materials, and it will improve the efficiency and effectiveness of the work practices in the enterprise. See, the Industry 4.0 will have machines. Like any other enterprise, it will have machines. These machines will have sensors. And these sensors, when the machine is functioning, will be emitting out some signals. These signals will land onto the computer and it will be analyzed, and the corrective action will be sent to the IoT, which is connected to the machine. So the IoT between machines will talk to each other or communicate with each other and thereby control the performance. This is what is a basic Industry 4.0 machine. To work in such kind of a machine, you need to know about the skill sets which these enterprises are requiring to have. One, there will be an operational skill required, and another is the managing skills required for these Industry 4.0 or the enterprises that are evolving to come. The operational is nothing but connecting the machines. It is going to be simple, but it will require recall, relate, and refining skills in the employees. That is the major thing that is required in an employee. That is in addition to the core skill and the data analytic skills that are required in such employees who are going to be employed in Industry 4.0. Whereas the managing skills are common like any other places, like you have R&D, research and development, PTD, process and technical development, and SCM, supply chain management. These are the basic things on which an enterprise would be constructed. This is okay. But what will happen to the human being who is going to be employed in this organization, and what is the growth that is being planned for this person? See, an operator in an Industry 4.0 will have sensors, right? He will do the tethering problem or tethering the communication he'll do, and he'll plug and play the machine, right? This is operational. The next level for him is the conversion level. That is, the data has to be converted into information. That through smart analytics, where the machine's health, degradation, and performance of the organization is also taken into consideration. So thereby, he is learning from operating to becoming a maintenance guy for the machine. The next level for him from maintenance is the cyber systems. When he wants to get into the cyber level, he should know, as the machine is being connected to time and memory as its constraints, he should know how to cluster and data mine the information from the data and then use it for the betterment of the organization. This is called the integration level. Then the next level is called the regeneration level or the cognition level, where the employee goes for simulation, synthesis, visualization, diagnosis, and decision making based on the machine's health, performance, requirement, everything. This is called the regenerative level. The final level is the leader level. Leader level is nothing but the configuration of the total machine, where the self-control on the resilience, the variations, and any disturbances that happens to machine is also being controlled. That is the level of a leader. These are all okay. But how is it going to affect me? That's what you will be expecting. See, it is going to affect everyone. You be in whatever age group you are with a technical degree. Either you are waiting for an employment, or you are already in an employment, or you are going to retire and you want to get into a post-retirement. Be whatever levels you are. It is going to affect you. Because now we are in 2020. UNIDO, United Nations Industrial Development Organization, in its Agenda 2030, that is 10 years from now, what is to be done, they have planned. That is, in the year 2030, in its 9th goal, they have said to build resilient infrastructure, then foster inclusiveness, and then bring in industrialization, sustainable industrialization, and then go for making up innovation in a better way. So they are telling about 4 I's. One is the infrastructure, inclusiveness, industrialization, and innovation. These are going to be the basic points on which the Industry 4.0 is going to evolve. You see, infrastructure. Infrastructure is what? Wherever we are staying, wherever we are going, whatever we are doing, those people who are coming and buying from us or getting the services through us, the buses, ports, seaports or airports or whatever it is, the connectivities, the bridges, the dams, whatever the infrastructure we are creating is all done by civil engineers. So civil engineers will have their job. So they have to just polish and go with the changes that's happening in the structural requirements of the buildings or the infrastructure. They'll have their job. The second point is inclusiveness. Inclusiveness means as part of globalization, what happens is the globe total is going to compete for job. It's not one region which is going to compete for a job. So everyone is equal. So it is going to be a diverse and a pluralistic society which is going to be employed. So we have to sharpen our skills to be competitive with the global environment. So HR people have to know how to handle this with the existing employees or when they are going to recruit the new employees. Then comes the industrialization. I'll take industrialization in the last part. We'll go with innovation first. Innovation is nothing but everyone wants to have a novelty in their life, new things, upgrades. Even with smartphones, we are not happy with having the same phone which was 2 years ago. We want to have changes over every time whenever a new variant is being released. So we are comfortable and we are willing to go with new things. So innovation, creativity is going to happen and we have to be going through that process. Now coming on to industrialization. Industrialization, they have identified about 5 clusters. One is called the bioscience, medicine and healthcare. This is the first cluster they have taken. The second cluster is the energy, which is the generation and distribution. Third is the aerospace, which gets the defense, which gets the aerospace, and then goes with the transportation, and last is the ICT enablement. Let's see each of this in a shorter way. One is the bioscience, medicine and healthcare. They want to come out with bioactive and biocompatible drug delivery. In the sense, whenever you take a medicine, it will go into your system and it will correct all your ailments. You need not worry about it. It will identify, it will go check and it will set you right. Another thing is the dressings and scaffoldings. Whenever you get injury, you put some dressings. Those things have to quickly heal you. They have to get you ready as quick as possible without much pain and any part loss, human body. So you get that limbs or human parts and replace it. Either you have an artificial one or harvest it and put it. So you get it quick and your lifespan is also increased. The third one in that bioscience, medicine, healthcare is they want to go with antimicrobial surfaces and materials. In the sense, like now in COVID-19, we have the virus being sitting onto material. So when we touch it, we get the disease. So they want to go for antimicrobial in the sense that whatever microbe is there, it cannot get settled on a surface. And such kind of materials are going to be made. These things are happening. So bioscience, biotechnology, veterinarians, all these medicine people, they'll have their jobs. Now coming on to the defense. The defense, as I said, they are going to concentrate more on the aviation segment. When they are going for an aviation segment, they cannot lose anything. When in sky, if anything happens to the flight, it is a complete catastrophe. So they want to have quick sensing or self-sensing and self-repairing composite structures and materials. In the sense, anything happens in the sky, they'll quickly change and the material itself can now reconstruct itself so that it is safe to come back. It means the metallurgy people, the material science guys will have a good job. Then the power. Power is where we have to go with the current form of generations and distributions may not work out in the near future because they want to have clean, secure, affordable power. And they are not willing to take hazards in their life. So a new power generation and self-sustenance has to happen. So the power engineers, electrical engineers will have job, but they may not have it in their native places. They have to go wherever the job of generation and distribution is happening, so they get their fitment into it. The last part is the ICT enablement. We have the transportation. Transportation is going to be lightweight. Lightweight means alloys are required. Structural changes will happen in the transporting vehicles. Already IC engines are being replaced with electrical engines. So many of the IC engine experts may not find their position, because electrical engine with less weight drives are being implemented. It will go more. It may go for autonomous vehicles, auto-guided vehicles, and all the stuff will come. So it will be interdisciplinary requirement for transportation. Then finally coming to the ICT, because now the whole world is towards computers and informations. So how this data and a physical machine can coordinate is the one which is going to be seen. See, when industrialization happens, urbanization will happen. In the sense, a lot of people from the rural will come to urban in search of job, and they'll settle. As they come and cluster and come to the cities, what will happen is overcrowding will happen. So ICT will be towards solving these problems. One, traffic congestions. ICT will take care of the traffic congestions. One, and then second is your centralized vehicle system or transporting system. So that will be ICT enabled. Then you will have drivers, intelligent driver information systems, where any driver who takes a vehicle, he'll automatically be guided from destination to destination, so that he just needs to put the GPS on and put the mode of the vehicle into autonomous mode. So it guides you. GPS will guide you, GIS will help you. So you can easily safely go to your destination. And you can also know how much time it will take, where your problem of traffic is there, whatever it is. It can help you out. Then the last part is disease identification. That is through data mining. You will have go with machine learning and identify widespread diseases where they are, so that you don't get near the disease and you keep away from the disease. So such information systems are going to be evolved. These are all the jobs that are this requires again interdisciplinary. This interdisciplinary will be with computer science, IT, mechanical engineers, and electronics and your communication, ECE guys. They will have. So these things are the jobs available. So now you're already into this only. But still, how it is going to affect you? The reason why I'm going to tell you about how to position yourself for the future employment is, as long as we live, we need to be in a position to earn money. Either by doing work to an organization or to self-generate an employment, becoming an entrepreneur. I'll give you the skills that is required, and it has been foreseen. CDIO, that is conceive, design, implement, and operate. They have given certain standards, meaning that they identify potential and optional standards for Industry 4.0. They are the ones who give advanced and broadened competence that is required to be equipped with for Industry 4.0. Before I go further, I'll tell you, there are two things that we need to know. One is the skill. See, whatever learning we have through engineering education is only knowledge. This has to be converted into skill. It means it has to be applied. So what is the ability to do it is called skill. And we require competence. It means the capability in an effective way. It means successfully completing a job is called competent. So CDIO gives the competent skills that needs to be developed for the future. They have identified many areas. Okay, I'll go on with it. But Industry 4.0 has some functionalities. One, it is called the interoperability. That is, communication happens between the machine and the data through computer. So interoperability happens. Then transparency. What data you are seeing is the same I see. So it means nobody can hide with it. No inferences need to be done with the data. Data is data. Then comes the real-time acquisition and processing of a data. So it is not on the past or on the future. It is on the real time. We have to do the corrections. And then the last one is the digital automation. So everything is a system which is controlled by a digital mode. But these functionalities are not frozen. It is still in a fluid state for Industry 4.0 because we don't know how it is going to evolve. But by all practical reasons, Industry 4.0 can be defined as a cyber-physical system with AI, ML and predictive modeling of data. What is AI? AI means, see, every one of us have intelligence. Intelligence means what? Out of our past experience, we know how to refine and position ourselves. See, if something is going to burn, we don't touch it because that's our experience. So how that kind of experience given to a machine? That is called artificial intelligence. To make the machine be learned enough to accommodate itself. Artificial intelligence is nothing but data. It is processed in an algorithm. It means the formulas are created and then it is fed with past experience. Past experience is nothing but an enterprise has certain base records like performance, productivity, quality, all such. Those are fed into it and then you adjust it or scale it up. This is the intelligence part. Then comes the machine learning. Machine learning is nothing but it's like a stimuli response. Stimuli response is if an ant is going to bite you. Will you search for the ant and then hit it? Or if a mosquito is going to bite you, are you going to wait for it and then hit it? Or if a fly is going to fly over you, are you going to shove it off with your hand? Yeah, will you use all your brains to find out? No. It is stimuli and then you get a response. Like that, a machine will know how much of force is required at what time and how to be handled. It's called machine learning. It's an auto programming of a machine connected with the artificial intelligence. This is what is the phase of Industry 4.0. But this will be dependent on the technologies that are going to drive it. Technologies for now, I will limit myself other than bioscience, medicine and healthcare. Also agriculture and veterinary. I leave out all these 5 segments and I'll come to non-life product services technologies. To understand this, there is an acronym which is called 2S, 2C, 2A, IBR. 2S, you will have simulation, systems integration, cloud computing, and then you will have cyber security, and then you will have additive manufacturing, and then AR, augmented reality. Then IoTs is I, and B is big data, R is robotics. So 2S, 2C, 2A, IBR. First is the simulation. Simulation is required in any engineering because before you go venture more, take a risk, you want to see how much is the practicality of your work. It starts with your design, it goes with your product, it comes to your services, it will take care of your safety, it will take care of your usability, accidents, hazards, be whatever it is. So all those things can be simulated even before it is really made. So this is the big part of engineering. So there is a lot of simulation tools available. You have to pick which you want to get sharpened with and then be ready with it. There is a lot of scope for simulation tools, technology being taken as a competent skill. Then comes your systems integration. Systems integration is nothing but you have a machine, you have sensors, the sensors will spike out data, that is the signals. So that's the information. So you need to connect all this, integrate all this. That's the hardware and software to be connected. It's called systems integration. Okay, how to do it? In enterprise, there is a vertical integration and then there is a horizontal integration. Vertical integration means whatever goes into the enterprise has to come out. So raw materials goes, a lot of product, production processes go, and then you do the quality aspects, do maintenance aspect, do whatever it is, and then the final product goes. So this is intra-enterprise. This is called vertical integration. And then horizontal integration. What your enterprise goes through also happens in your competitor. For example, you are buying materials. You are buying materials, and this, from the same place your competitor also will buy it. You will have some vendors, they will also have the same kind of vendors, or the same vendor also. You will have some kind of suppliers, they will also go with the same kind of suppliers. So it's you cannot define it, because these people are small players. They can go wherever the business is. Similarly, you have to identify how to integrate that people, that is with yourself. Then in the marketing, you make a material and you move to your warehouse, stocking, distribution. All these things are in the common place. From there only it will get to the market. So how to integrate this? This is enterprise. This is horizontal deployment. So those specializations which goes with the operational research, all these things will have their say into it. Now coming to cloud computing. Cloud means what? It's a pathway. It's a pathway to deliver the computer services, computing services. It can be servers, storage, network, DB, software, analytics, be whatever it is. All these things have to be simple, safe, secure, scalable, innovative, affordable, and flexible. Many things have to be ready. So you find out where you want to venture into, position yourself and get trained in that area and use that kind of a technology. Then the cybersecurity. Lot of people are going to be used in handling data, but all cannot be given access to all the data. So only few will be given rights, and how that rights have to be assigned, and who has to be assigned with such rights of editing or saving or whatever it is. What rights you are going to give? Read, write, save. Whatever rights you are giving, how to give it. Then in case of any problems, how to trail back or trace back it. So you need to have trails. Then you need to have, if you want to bounce back, okay, forget all these things, and I want to bounce back quickly. So I need to have a disaster recovery system, DRS. But all these things are to prevent yourself from intrusions, malware, hacking, and then reduce the impact of your incident response. All these things have to happen. This is where the cybersecurity comes. The next part is your additive manufacturing. Additive manufacturing is called 3D manufacturing, 3D printing. See, the current way of metal formation, like casting, forging, whatever it is, forming operations you do, and then joining operations like welding, fabrication, whatever you do are going to be, going on. It will be in a flexible way. You're going to have optical fabrication, photo solidification, fused deposition. All these things are going to replace the current manufacturing processes. So we have to be positioning ourselves for a better way, because those are the things which will have less amount of inventory. It will go with quick, flexible and quick manufacturing methods, and you can quickly deliver to the customer, and you can save cost. Many things are interconnected. So the future is going to be on novel manufacturing methods. That is additive manufacturing. Then comes the augmented reality. Augmented reality is nothing but, see, if you know about Google Earth. Google Earth, you click on Google Earth, you see from the Earth, you go down, you see some water, you see some landmass, and then click on the landmass, you will go to continents and click down, you go down to the regions, and then go down, you come to countries, then to cities, towns, roads, buildings, like that. And from 2D you change it to 3D, you can. All these things are nothing but overlay of digital information and content. Similar thing is going to happen in our normal way of work. That is called AR, augmented reality. There will be a wearable. You wear it like a glass. It will be linked to the computer. So as you reach that position, the computer will sync with the reality, and it will inform you how to go, what to do. What is the next step you have to do. If it is connected to a telewatch, like you have drones and things being signaled to your computer, then you can even see from a third eye, and it can help in safety levels, many things. These are augmented reality. Then IoTs, Internet of Things. See, Internet of Things is nothing but connection of a machine with a digital machine, and then you have a kind of a communication happening. See, in autonomous vehicles, or autonomous inventions that is going to go forward, We are going to have exponential AIs, quantum computing, and then bio-digital integration. All these are going to come. Okay, these are quite higher levels. It means it requires a lot of algorithm creations. It goes with a lot of quantitative researches. So if you are more onto numbers, then go with AI. And if you are interested in hardware and software integrations, also then you can go into AI. And then comes the big data. Big data is nothing but you have voluminous data. Voluminous data is going to be made into an enriched data by warehousing. It means storing it safely, computing, working on it, and then engineering it, classify it where what is to be seen, and then you go for mining it, take a right decision, and then filter it, then use it for your requirement. This is how the big data will come. It will all be linked to RFIDs and things, radio frequency identifications. So as a person reaches a shop, even before he goes and picks the item, what he is going to pick, the shop owner will know what he is going to pick. Such will be the information that will be transferred about a customer to the supplier. So there is going to be a lot of transparencies in the systems. Then comes your robotics. Robotics, if you see, it is a connection of lot of multiple cameras. If you don't have cameras, it will be an embedded visual systems or vision systems, which will control the total automation in such a way that it will give a deterministic positioning and actuation of an activity. So all gripping, holding, devices, combining, everything, even in areas where it is hard to access or it is with contaminations, all these things can be avoided with robotics. So people can have a good quality of life. Right, so you can pick any of the qualities which can be enriching you onto competence skills development, because tomorrow's industry requires only skill and quality which will be the competitive advantage giver for an enterprise. So if you want to have an employability, position yourself and pick accordingly, so you will have a better future.